Now, polynomials for standard 10. This is the topic is in algebra, polynomial. Here, the relation between zeros and coefficients of a quadratic polynomial. Relation between zeros and coefficients of a quadratic polynomial. Already we are knowing the quadratic polynomial. Their standard form is ax square plus bx plus c, and zeros. Zeros means the solution. Whatever the solution of quadratic polynomial, their zeros means for which value that quadratic polynomials remains zero. That is called zeros of quadratic polynomial. If it is any quadratic polynomial, then there are two zeros. So the relation between zeros and coefficient, the quadratic polynomial, their standard form is ax square plus bx plus c, and their coefficient, the coefficient of x square is a, the coefficient of x is b, and this is called constant term. So the relation between zeros and coefficients of a quadratic polynomial means whatever the zeros we are having, that zeros gives what relation between this a, b and c. Whatever it is, the coefficient of x square, coefficient of x, and constant term. So now let alpha and beta be the zeros of a quadratic polynomial px is equal to ax square plus bx plus c, where a is not equal to 0. This is quadratic polynomial format ax square plus bx plus c, where a is not equal to 0. Then x minus alpha and x minus beta are factors of px. Because alpha and beta are the zeros, it means x minus alpha, x minus beta are factors of px. If it is factors, then ax square plus bx plus c can be written as equal to k into x minus alpha into x minus beta. Because alpha and beta are the zeros, therefore x minus alpha, x minus beta are the factors. So their product must be equal to that quadratic polynomial. Now ax square plus bx plus c is equal to k into big bracket. This will multiply. When we multiply x minus alpha, x minus beta, then it becomes x square minus alpha plus beta into x plus alpha beta. So ax square plus bx plus c is equal to kx square. Multiply this one, kx square minus k into alpha plus beta into x plus k alpha beta. Comparing the coefficients of x square, x, and constant term on both sides. Now we compare the coefficient of x square in both sides, the coefficient of x in both sides, and constant term. So here ax square and kx square, when we compare, then a is equal to k. Second one is here bx. So coefficient of x is b, and here the coefficient of x is minus k into alpha plus beta. So b is equal to minus k into alpha plus beta. So b is equal to k is equal to a. So substitute here the value k is equal to a. So minus a into alpha plus beta. So alpha plus beta is equal to minus b by a. Similarly, when we compare the constant term here it is c, and here it is k alpha beta. So c is equal to k alpha beta. Again, k means a. So c is equal to a alpha beta. So alpha beta is equal to c by a. Now, what we observe here, alpha beta are the zeros of quadratic polynomial. So this can be written as sum of zeros alpha plus beta. Sum of zeros is equal to minus b means what? the coefficient of x square. So coefficient of x by a means coefficient of x square. So sum of zeros, it means whatever the zeros are there, if we will take their sum, then that sum must be equal to minus coefficient of x divided by coefficient of x square. Similarly, alpha into beta, that is product of zeros is equal to C. C means constant term. Whole divided by A means coefficient of x square. This is the relation between zeros and coefficient of any quadratic polynomial. Sum of zeros is equal to minus coefficient of x by coefficient of x square, and product of zeros is equal to constant term divided by coefficient of x square. Find the zeros of quadratic polynomial x square plus 7x plus 10. Find the zeros of quadratic polynomial this one and verify the relation between zeros and coefficients. This is very common question in polynomial, quadratic polynomial. Means first we will find out the zeros, and after that with that zeros we will verify the relation between zeros and the coefficient. Now first part, find the zeros of this polynomial. So x square plus 7x plus 10. First we will factorize this one. So this is trinomial factorization. X square plus 5x plus 2x plus 10. Now x common, x plus 5 plus 2 common, x plus 5. That is equal to x plus 5 into x plus 2. Now the question is, find the zeros of this quadratic polynomial. It means this product must be equal to 0. Then we will find out their zeros. So now x plus 5 into x plus 2 must be equal to 0. It means x plus 5 is equal to 0. So x is equal to minus 5 and x plus 2 is equal to 0. So x is equal to minus 2. Now these two are our zeros of quadratic polynomial x square plus 7x plus 10. If you will substitute in place of x minus 5 and minus 2 separately, then this polynomial must be equal to 0, which is called zeros of quadratic polynomial. So the first question answer is, find the zeros of the quadratic polynomial. So therefore minus 2 and minus 5 are the zeros of a quadratic polynomial x square plus 7x plus 10. This is the first part of the question. Second part is, verify the relation between zeros and coefficient. So now we will verify. Sum of zeros. Now you see, sum of zeros, minus 2 and minus 5 are the zeros, so their sum is minus 2 plus minus 5. That is equal to minus 7. So that minus 7 can be written as minus 7 by 1. Now you see, 7 is the coefficient of x and here it is minus 7. So this can be written as minus coefficient of x divided by, what is the coefficient of x square? C by a, minus b by a. So minus coefficient of x divided by coefficient of x square. So minus 7 by 1, which can be written as minus coefficient of x divided by coefficient of x square. minus 7 by 1. Here it is 1. So sum of zeros satisfied. Similarly, product of zeros is equal to minus 2 into minus 5. That is equal to 10. 10 can be written as 10 by 1. Now you see 10. 10 means what? C. C means constant term. Whole divided by coefficient of x square. So it is verified. Sum of zeros minus 7 by 1. That minus 7 by 1 can be written as minus coefficient of x by coefficient of x square. Product of zeros minus 2 into minus 5, that is 10. 10 means 10 by 1. So that can be written as constant term divided by coefficient of x square. This is very common question. Find the zeros and verify the relation between the zeros and coefficients. In that way, any quadratic polynomial is given, and if it is given to find out the zeros and verify the relation between zeros and coefficient, in this way we can do it. First we will factorize that polynomial, maybe sometimes factorizable by middle term splitting, maybe factorizable by difference of 2 square. So first we will factorize it, then that factor equate with 0, separately find out their values of x, and then find out the relation between zeros and coefficient.